not able to render its data or its display enough times in terms of the refreshes. So screens will have refreshes. Typically they render at 60 frames per second, and if your app is not able to actually do its processing in time for each of those frames, you get these situations where you miss the frames, and so you end up repeating the last frame that was rendered. So if you think about an animation, it's what results, the user sees this choppy or stuttery or jittery animation rather than something nice and buttery smooth. So Project Butter is all about fighting and killing jank. And we wanted to really improve what's there in the Android framework to give you a jank-free experience. But before we go further, I would like to talk about VSync. VSync is something called vertical sync. So to give you an idea of how VSync works, our mobile phones and tablets, they refresh their screens at 60 frames per second. And at every time that it's about to draw a new frame, a control signal known as vertical sync is actually fired off. So at 60 frames per second, it means that your app has roughly 16 milliseconds to get its work done in order to have that next frame ready. So what we did in Project Butter is now start to control a lot of our timings based on this VSync control signal. So Project Butter is really about three things: VSync, triple buffering, and combating input latency. So firstly, let's talk about how we're using VSync. So here is a fairly complex looking diagram about how things used to work prior to Jelly Bean. So we have three lines over there, and you see the top one is the display line. So that's the display, and the numbers in those displays is the frame number that is being displayed. So what your app needs to do typically, or even the framework what it needs to do, is have the next frame ready at the time those VSync points occur. And you'll notice that in frame 0, at the time we drew frame 0, the CPU and GPU were able to do their work within the necessary time period. So you'll see that we have in the second column, frame 1 was displayed without any problems. But after frame 1, you'll see that the CPU started working partway through that frame, and so by the time the next VSync occurred, the GPU hadn't actually had enough time to get its work done. So rather than displaying frame 2, at that VSync point, we ended up drawing frame 1 again, and that's where we see jank, because we've repeated a frame rather than have that next frame ready. So that's how it used to work without VSync. Now we're going to see how VSync is being used. Now the difference here is, yes, we don't see jank, but the big thing to notice is that at every time that the VSync point occurs, that control signal is passed, the CPU gets an opportunity to do some work. So as soon as frame 0 is finished, we get that VSync, we're immediately starting to work on frame 2. I'm just going to go back to the slide, and to the old way, you'll notice that blue 2 in the CPU line we didn't start working on it until after some point in time. Whereas now with the new method, and this is again now the new method, as soon as VSync occurs, we say, all right, CPU, it's now time to do your work. So now we're actually giving the application a lot more time to get their work done before the next VSync. Now you have to be careful here, because there's still, if you code your application in a certain way, you could still spend more than 16 milliseconds in doing your work. So as an app developer, you do need to be conscious of how much time you're spending processing, but at least the framework is no longer holding you back because we're using VSync. So that's VSync. The next thing is something that we call triple buffering. But before we talk about triple buffering, let's talk about how it worked with double buffering. So prior to Jelly Bean, we used something called double buffering. Now you might be wondering, what are these buffers? Well, double buffering is about having one buffer where the frame is ready, so the display can just draw it, and the next buffer, which is your working buffer. So it's like here, draw this buffer while I work on buffer number 2, and then when I'm done, switch it around. So you're continuously going to be drawing A, B, A, B, A, B. Now, again, what you'll notice here when we use double buffering is that there was a time when the GPU, if you look at the green B, it's taking more time to do its work than it's actually got. So when that first vsync point occurs, buffer B isn't complete. So we have to draw buffer A again. So then we draw buffer A, and then the vsync point occurs, and then we start working, so now we draw buffer B at that second vsync point, and we start working on buffer A. But again, buffer A's work doesn't get completed in time, and we end up repeating buffer B in column number 4. Now you'll notice in that second column, so the first time we get a jank, there's a whole bunch of time where neither the CPU nor GPU were doing anything, and that's really inefficient. So what we've now introduced is a third buffer, and that's why we call it triple buffering. And this is what it looks like now. So what we can do now is that when buffer A is ready, we'll draw buffer A, then we'll start to work on buffer B. But the key thing to notice here is that at that first vsync point, even though buffer B isn't complete, the GPU is working away, we can actually start the CPU working on buffer C. So that what happens when the next vsync point occurs is that buffer B will be ready, but most of the work for buffer C will also be done. So then by the time the next vsync occurs, we'll be ready. So we will have A, B, and C back to back, and we'll keep toggling. So this is how triple buffering helps. But you might be wondering, by introducing a third buffer, are we actually introducing latency? And the answer is yes. So what we've done is we've implemented it in a smart way. We will only trigger that third buffer, buffer C, if the buffer B is not already ready. So if you look at vsync point 1, we've had to go to buffer C because buffer B wasn't complete. But after that, we haven't actually done any work on buffer C again because we're actually finishing our work on time. So this sounds a bit technical, and we've tried to simplify it with this diagram, but the point is that's important to you is as long as you can get your work in your app done within 16 milliseconds, you'll be fine. So that's two things we've discussed, vsync and triple buffering. The next is input latency. And input latency is all about after a user touches something on their screen, how quickly is it displayed to them that they had that interaction. So let's look at another somewhat complex graph. This is how it used to work. And this graph is slightly different to the one we looked at before. We have the user input events across the top. So if you think about a drag operation where the user is touched on the screen and is dragging their finger around, we're getting a whole bunch of user input events. Then we have this component called a dispatcher, which would trigger every so often. And at the point that the dispatcher triggered, it would take whatever queued user input events we had, and it would pass it to the activity. So that's that first blue A.C. And you'll notice the dispatcher gets those events, passes it to the activity does whatever work it needs to do with those events, and then draws it. But by the time it's drawn it, we've had a whole bunch of more events. So if we look at it from a latency point of view, at the end of the first draw, the user has seen inputs A to C, even though we've actually had A to N inputs. And as time goes on, this lag or latency is only going to get worse, and the dispatcher actually struggles to keep up. The problem keeps getting worse and worse, depending on how many input events are coming through. So that's why you start to notice this difference between when a user interacts with the screen and when they can see the outcome of that interaction. So that's how it all worked before. It was not so efficient, but we've improved it. And this is how it now works. You'll notice now that we have these vsync control points. So we use vsync to tell us, hey, at what point should we grab those input events? So the dispatcher is no longer needed now. At the point we get a vsync, the activity gets all of the queued events, and it processes A to F and does a draw. So if we have a look at the latency now, at the end of that first draw, we actually have A to F drawn, not A to C. And at the end of the second draw, we now have G to O drawn, so we're not actually falling as far behind. Now you might be looking at this and saying, well, there's still a little bit of latency. Yes, sort of. Each VSync, if you remember back, each VSync is one frame that's being drawn. So when you look at the second draw point and you say, okay, well, O has been drawn, by which stage we've had P to X, it's only off by one frame. It's only off by 16 milliseconds. And it's no longer struggling to keep up. So you're looking at about a one frame latency there, and you might be saying, what does that mean? Is that good or bad? Well, let us tell you, it's actually really, really good. It's fantastic performance. Many of the touchscreen like the touchscreen hardware in the devices actually can't even pass in the user input events to the framework at that speed. Typically, they can introduce a latency of up to 5 frames. So what I'm trying to say is this 1 frame a second from the framework is actually really fast and well ahead of what the current day hardware can provide us. So we have some room to grow. So that's Project Butter, the 3 things that we've improved. VSync, and we're timing everything on VSync, then triple buffering and input latency. And with that, I'll hand over to Tony.
Yep, so let me talk about rich notification. So this is something we have a complete revamp in Jelly Bean for notification. And next slide, please. So this is how it looks like now. You can see the content is much richer, and each of the notification occupies what we call more units compared to the past. If you remember, the height we have for each notification, we call that 1 unit. And now, next slide. So we have the expandable notification can occupy up to 4 units, which is 256 dp. And we also introduced priority for notification, which we will talk about this in detail in the design session in the next session. So the priority will give some hint to the system to prioritize which notification should display first. And also, action on notification is now first-class citizen. So there are things like you can do a directly call back to call a person, do a message, or just snooze an alarm notification. Those things can all be done within notification without even going to the full application. Next slide. So the good news, the icon design, all the guidelines for icons are still the same. What we set in ICS still the same in Jelly Bean. The semi-good news, good news to user, but maybe a little bad news for you developer is now user can disable notification on a particular application. But in some way, it's really a good incentive for developer to create a good user experience on notification. It's an incentive to do it right. So next slide. I think Ankur is going to talk about SDK tooling.
Thanks, Tony. So SDK. All developers have to use the SDK to build Android apps, and we've been making improvements constantly with the SDK. So the first what's new in our tools is that the emulator has gotten faster. Now, for those of you that have used the emulator in the past, you know that it's been slow, and you know it's something that we've been wanting to improve. So the first thing that we've done is we've added x86 virtualization. So let me just give you a background on what that actually means. Today, well, prior to this, what happens is that when we emulate the ARM architecture in the emulator, we're emulating the whole infrastructure, the memory, the GPU, the CPU, and it's all virtualized on your device. So even though you may have these super fast 2 and 3 gigahertz CPUs, we have to emulate the whole infrastructure, which really slows it down. So the first thing that we've now done is that we've introduced x86 virtualization. So you can actually get emulator images for Android 2.3 and Android 4. The Jelly Bean image isn't available yet, but we're working with our partner Intel to bring that to you. So the way that this image works is that you have to go into your SDK tools and just grab the relevant image and then create a new AVD with the x86 virtualization. So it boots up, super fast, and it's really quick to use. It really is great. On top of x86 virtualization, there are still apps that need to use the ARM infrastructure. So things like native apps, for example, are targeted for ARM architectures. So you still need that the ARM emulator. Now, what we did is, for emulator images that are from ICS and upwards, we've added GPU support. So let me just give you a background on one of the big bottlenecks of the ARM infrastructure when it's being emulated. So if you look at running a Gingerbread or even a Froyo emulator image, it seems to be a lot faster than running something like the Honeycomb version. And the reason for that is that we've introduced newer versions of the platforms, you'll notice that we also have higher resolution devices and higher resolution screens. Now, when you're emulating that big graphics subsystem and you're pushing that many pixels through an emulator, we just struggle to keep up, which is really why they've seemingly slowed down over time. It's just that we're pushing a lot more pixels. So with this new option that we added to the emulator, instead of emulating that whole graphics infrastructure, what we do now is we do GPU accelerated rendering. So it'll actually use the GPU on your device, on your computer, to render the graphics, and you get, I wouldn't say native speeds, but significantly improved speeds. We've been working with some game developers that are actually able to emulate their games now reasonably well on the emulator by enabling this option. The other thing we've done is improved our sensor support. So what we do now is, for example, multi-touch. Most people don't have more than one mice, and it's really hard to control it. You don't have more than one cursor on your platforms. So what we do now to enable multi-touch support is that you can actually connect up your Android device via USB cable to the developer tools, and you can use your let's say your Galaxy Nexus as an input for your emulator. And that way you can actually get your 10-finger multi-touch, and you can debug it, test it, so on and so forth through the emulator. We've also, of course, been improving the actual tools themselves. So my favorite improvement actually is lint. Now, lint is a compile time check that we run to try and catch common mistakes. So things like whether you've externalized your strings, localized them. If you've explicitly hard-coded strings in your source code, lint will give you a warning to say, hey, this is, if you run this app in French, it's still going to show you the English text that you've supplied, so you're better off localizing it. And it actually not only gives you those warnings, but in many cases, it gives you a quick fix. So you can just right-click that string, for example, and say externalize it, and it will move it to strings XML and set it all up for you. So it's really nice. I use it all the time. For people that are doing OpenGL apps, we've added a tracer that really gives you every one of those OpenGL calls that you're making so that you can truly debug and see exactly what's going on. Now, we've always had Device Monitor. We've actually improved the tool significantly now. So it has a much better user interface. And System Trace is also a new tool that we introduced that we actually used quite a lot for Project Butter. So what we typically use it for is to try and see how much time is being spent, in terms of those your CPU-bound operations. But you can check all sorts of things like memory usage, so on. So System Trace is it's a very technical tool, but once you learn it, it's really useful. For those of you that are doing NDK apps as well, we've been improving that side of things continuously. The build system has been improved. You can now also debug native apps. So for whenever I tell people that, hey, we now have debug support for NDK, those NDK developers always jump with joy. So I hope if you're an NDK developer that you're using this already. Our layout editor has also gone through a fair few improvements. So now we've actually got a nice way to specify which device configuration you want to view. So within the layout editor, you can actually see, hey, how does this particular layout render on a Galaxy Nexus or a Nexus 7? So it allows you to test all these different devices just within your dev environment without actually physically having a device or going through the debug process of running it, installing the APK, and seeing what it looks like. We also are introducing this feature where you can actually say, I want to see the Galaxy Nexus, the Nexus 7, and the Motorola Zoom all at the same time for this layout. And as you modify things on your layout, it will render them simultaneously so you can see them all at once. So this is just to really speed up your workflow. The property sheet side of things has improved as well. So where you set your properties for your views, it's grouped a lot nicer now. Just the general user experience is much better. App templates are great as well. We've now added some. Basically, what it does is you can say, hey, it's like a wizard. So you can say, go and generate me this style of app or this style of activity, and it actually goes and does a whole bunch of work for you. So you don't have to go and do every little, all the boilerplate stuff yourself. It handles it for you. And in general, we've been trying to improve the tools. So the XML that we produce from our various editors is formatted a lot nicer and it's a lot more readable. And we've also been working on improving the performance within Eclipse as well. So in general, SDK Tools is on a very positive trajectory. Tony.
All right, so let's talk about building Android application using web APIs. So we know not all Android applications are standalone, and sometimes you guys may need to talk to a server to fetch data. So we make it easier. Next slide. We make it really easier for you to do that now with something we introduced back in Google I/O called Google Cloud Endpoint. It's really very easy to set up a REST-based API on App Engine. So all you need to define some models on App Engine and then do some proper annotations. So you have your REST API right there. Another thing that's going to come up really, really soon is what we call Google Play Services. So for those who have done OAuth implementation, you know how difficult that could be. So we acknowledge that, and that's what we're going to offer in the Google Play Service is an OAuth 2 implementation. So make it really easy for developer to just integrate and have OAuth integrated to your application. Through Google Play Service, there are also some new APIs coming up, and one of them is Google+, and there will be more coming soon as well, so stay tuned. The next topic I want to talk about is Google Cloud Messaging. So this is what we used to call C2DM, Cloud to Device Messaging, and we recently rebranded this to GCM back in I/O time. Next slide. So there are some new things in Google Cloud Messaging. So first, again, it's still free and with unlimited quota now. And another new feature on GCM is now it supports something called multicasting. So in the past, if you want to reach 1,000 Android devices, you need to make 1,000 call requests. But now with multicasting, all you need to do is send one single request with 1,000 messages in one call. Another new thing we introduced in GCM is we now support a 4 kilobyte data payload. So in the past we didn't recommend you to developer to include payload, but now we have that new capability. Yep. Anchor, I think.
Yeah.
Yeah.
Thanks, Tony. So we've made a lot of improvements in Android in general. So some of the other improvements that we have is in Jelly Bean actually is relating to user interface. So we've actually added animations for activities. So you can specify your own animation. An example of where we use this to good effect is if you look at the launcher on the home screen now, when you tap an icon to launch an app, the activity will actually come from the location of the icon. And that's using those same APIs that we've now introduced. So you can say when I'm showing my next activity, animate it from this point or animate it using this particular animation, and you can really control that experience and override the default animations in a nice, consistent manner. We added a great way for widgets now to actually respond to size changes. So, in previous versions of Android, we allowed you to say that your widget can vertically grow or horizontally grow or both. But now we're actually able to notify you that, hey, there's a size that's changed, and you can actually, using those events, you can actually change the layout that you're presenting to the user based on your new size. Now, something that not every Android developer tends to know is that the text view control is really a base class for many of our views, our UI views on Android. So what we did is we spent a lot of time improving text view and things like memory usage and performance. So by doing so, you actually get those benefits across a whole range of other UI controls. So those are really important. Now, with Android, you've always had this sort of backstack navigation, and you've been able to say when I go from one activity to the next, or when I use a fragment transaction to go from one fragment to the next, you could manipulate the backstack to kind of control the experience of when the user hit the back button to give them the right context. Now, you can still do it the way that you did using your Java code, but now we've actually we've implemented a way for you to specify backstack navigation in your XML layout files. So in your actual activity, you can say something like when the back button is pressed, go to this other activity instead. So you can do it via code if you want, or you can take the streamlined approach via XML now. We continue to improve accessibility and also data access. So one thing I want to talk about is the fact that we're making a change in future releases. So let me frame this a different way. If you are writing an Android app or have written an Android app that requires your app to be able to read external storage, so things like the SD card, you need to request this permission. This is a new permission called Read External Storage. Now, in Jelly Bean, we don't enforce that. We've introduced a permission, but we don't enforce it. But in a later version of Android, we will enforce it. So if your app isn't requesting this permission and is accessing this external storage, your app will start to fail. So as you now write new apps or update your existing ones, please go ahead and add this permission if you are accessing external storage. So this is just a heads up. Android Beam is something that we introduced in Ice Cream Sandwich, and it basically allows you to have two devices in close proximity to one another, and using NFC you can transfer all sorts of cool information, things like bookmarks, map locations, and so on. Now, one of the limitations of Android Beam was that you would typically have small amounts of data transfer. So what we've done is now we've lifted that restriction. So what happens is when you use Android Beam on Jelly Bean devices and you have a large transfer, it will use that Beam conversation to set up a Bluetooth connection between the devices and use Bluetooth to manage that large file transfer. So yeah, it's really useful. Tony.
So let's talk about Nexus. Next slide. So as you guys already know, we launched our new release Jelly Bean back in I/O, and we now added a few family members to the Nexus 9. The first one is the tablet, our new 7-inch tablet Nexus 7, and also we also push updates to some of the older devices like the Galaxy Nexus and the Nexus S and the Motorola Zoom. And one thing about Jelly Bean is it's already open sourced. So if you want to check out the source, feel free to go to AOSP. It's available there already. Next slide. Again, this is our new Nexus 7. As probably you guys already see that a lot on the internet already. So something I want to talk about in specifically good for developer in terms of development. So next slide. So when you develop application for Nexus 7, there's something to keep in mind. So the first thing is the Nexus 7 has a DP screen size of 600 times 960 DP, and the best way to allocate like resource layout for the 7-inch device is using the qualifier SW, stand for short width 600 DP, and that's the best way to target this particular category of form factor. Same thing for layout. So for 7-inch tablet using that qualifier, and for 10-inch using 720 DP. So that's a small tip for people who are interested in targeting this particular device. Yep.
Okay, so I guess I want to just talk a little bit about developer outreach. So as I mentioned, Tony and I are part of the Android developer relations team, and you can find us on Google+. You can certainly ping us with questions, development questions. We actually recommend you post really technical questions to Stack Overflow, because again, we monitor that, and there's a great community there, and you know, your questions are not only answered, but they're there for others to view. But if you have any specific types of issues that you're having, you know, feel free to let us know. We also run a whole set of events via Google+. So the first one the one that I really want to talk about is a new show that we're launching tomorrow. It's actually something that Tony and I will be running with some other colleagues, but it's actually called the Android Developer Lab Plus. And what it is, it's a weekly show that you can join in via Google+. We talk about what's happening in the Android development world. We cover presentations on specific topics, and we also give you an opportunity to ask us questions, either live or via a Google moderator link where you can post the questions beforehand. So we do our best to answer them there. So if you do have questions, and these are like the technical type, yeah, feel free to post them there. To know about when we're having these hangouts, you know, join the Circle plus Android developers, because we announce them there, or you can follow Tony and myself. So tomorrow is it's exciting for us because we're launching this new show. It's at a APAC friendly time. It's you know, at a time when Android developers can sign in. It's not in the middle of the night, for example. And we really are excited about this, and we look forward to meeting you on there.
Yeah, just let us know what kind of topics you guys are interested. So and let us know on G+, and we can arrange something and focus on these topics you guys would like to hear.
All right. With that being said, thank you very much. We hope you're enlightened by what we had to share about what's new in Android. A lot of what you saw today, you can actually see on the, you can find out more information about it on the developer portal at developer.android.com. But also be sure to go and check out the Google I/O videos that have been posted from Google I/O 2012 and even in prior years.